I watched too much of that show.
Going live, okay. So let's look at, you want to do D?
Yeah.
Okay.
On 4.
4D. So it's worth looking ahead to the purpose of this class is not to take quizzes, although it's kind of a necessary evil. When you take a quiz and the quiz says, it's only multiple choice, one of the wrong answers, emphasize the word wrong, will be, there's a discontinuity at 1. Okay?
Right.
Trying to see if you understand the difference between, what is happening at 1 on this graph? What is the function doing? It's an x-intercept. The function equals 0 there, but that's not the same as a discontinuity, right? So a function can easily, say, pass through the x-axis at 1 and still be continuous. So don't let that distract you. So the question is, what x value would cause problems for this function?
3 halves.
Yeah, so let's say it doesn't occur to you right away that the answer is 3 halves or 1.5. You'd go, well, what would make this expression equal to 0? Now what you've done, big thing in math is I've reduced the problem to a simpler problem, right? The question of where does this function have a discontinuity and what type of discontinuity, that's a high level question. We reduced it to a low level question. So you solve this. And there you go. So the x value that causes the discontinuity is 3 halves. Now I ask, well, what kind of discontinuity is it? If I plug 3 halves into the function overall, if I have 3 halves minus 1 over 2 times 3 halves minus 3. By the way, what's 3 halves minus 1? 1 half. I'd have 1 half over 0. That indicates that it is a vertical asymptote. Okay. How do you feel about that? Grape. Okay.
Can we do H?
For you, yes. Certainly. H. Or as the English would say, H.
That's weird.
Maybe not all English people. I don't know. I've just heard it before. H.
Which people are dumb.
Okay, just looking at this, does it occur to you right away that we got to do, what are we going to do to the bottom of this?
Simplify.
We're going to
Factor it out.
factor it, okay? Because I'm concerned, I'm asking the question, when is the bottom of this fraction going to be 0? So again, this is question H. And my markers are terrible today. Still believe in him though. I believe he might come back. They do, sometimes they get a little faint and then you let them rest.
I just need a break.
I think the juice needs to reabsorb it. Yeah?
Yeah, let
There
the
you go.
juices
But
get
that's not the one that
flowing.
you.
You might need to lean it against something.
Unstable equilibrium. No, I'm going to get it.
Physics.
Okay, there you go. It will not tip over. So the bottom of H, I can first factor out the x. Right? Everyone agrees with that?
Yeah.
Then I got to go further. I got to factor it one more time. So factor that. So what two numbers add up to -1 but multiply to be -6?
-3.
-3, +2. Okay, so there's going to be a lot going on.
Oh, it's gonna be
Cancel the one.
Because the first thing, so this is going to cancel this. What's left over on top?
1.
A 1. So I think I'm going to rewrite this because it looks kind of confusing to me right now. So we rewrite it as 1 over the quantity x times x minus 3 with a condition that x cannot be what?
-2. -2.
-2. Very good.
See that?
So that's a hole.
Okay, yeah, so this canceling out action created a hole at -2. So there was a hole at -2.
There's another.
Now, I think someone said, oh, x can also not be 3. You're correct,
Or
but
zero.
that's embedded, also 0, yes, exactly. But the fact that x can't be 0 or 3 is embedded in this equation. So you don't need to say it, it's like redundant, right?
Right, but aren't they different types of like discontinuity?
Very good. So those, since they're still there, notice if I plug in 0, I get 1 over 0.
So that's
If I plug in 3, I get 1 over 0. So those are both vertical asymptotes. Vertical asymptotes at x equals 0 and x equals 3.
How come on number 1 then we didn't do
Number one. Which one?
I mean
4A.
4A, yeah, because it's y equals x minus 4, and then x cannot equal -4.
Right, so on 4A, we had the top was x minus 4 times x plus 4.
Oh wait,
The bottom was x plus 4. So that cancels that, and you're left over with just an x minus 4.
You're not dividing by 0, so it's.
Yeah, so
Okay.
what you're left, so those canceled out, giving us the whole at -4, but this guy's is fine.
Okay.
So, anyway, if you're wondering, how does this look? I'll just draw it for you real quick. There'd be vertical asymptotes at 0, and 1, 2, 3. End behavior means it has to do this, and this, and there's got to be some kind of doodad in there, I think. So if x is between 0 and 3, it would be negative, but there'd be a hole when x is 2. Oh, sorry, -2. I misread it, my bad. Hold on, -2, sorry about that. So be over here. 1, 2.
Wonderful.
Does that make sense? Okay, so again, the two terms that cause division by 0 that are still left over in the function, those are going to create vertical asymptotes, and the term that got crossed out, that simplified out to 1, creates the whole. Okay. Okay, so G is going to have two discontinuities. One's going to be a hole, one's going to be an asymptote. Same with F.
How? Well, I don't really understand how you can tell it's like a jump or a hole or an asymptote.
Okay, so this was a hole because the term associated with the -2 got crossed out. So the fact that it's simplified out indicates that it's a hole. Okay, but these guys that are still there, right? There's nothing to cancel them out. Those are going to be vertical asymptotes. Okay, so we'll do one more example. So we'll look at G. So for G, question G is called G of X. Now that is a straight up Lamau, no cap. Got him, 21. Meme number, 21. Get it? Meme number. It's hard to be this hilarious.
I
you know?
forgot that
Yeah.
existed. 21.
It's an epic meme, is that what you said, Paige?
Yep, it's
Okay. So, factor. So the top is x times 1. Preparing myself to cancel out an x, right? The bottom is x times x minus 1. Ever cool with that?
Yep.
So
Cancel.
those x's cancel out. So let's think about that. That tells us something. That tells us the fact that it canceled out tells us there is a hole at 0.
Because why 0? Just because it's an
Because
X?
zero is what you plug in to that. make
Oh, to
one.
me, okay, yeah.
Because this term meant if we plugged in 0 into this
It'd be
function,
0.
we would have had 0 over 0. Now, who was the culprit there? Who was responsible for that 0 over 0? Well, it was this x term.
Okay.
But that x term cancels out. That indicates that it's a whole graph. What's the other x value that would cause this to be 0, or not to be 0 over 0? Sorry, to be dividing by 0. 1.
And that's the vertical asymptote.
But it's still there. Also, if I were to plug 1 into this formula, so here's a little table of values. More like a table of what happens when I plug in these problem numbers. Plugging in 0 gave us a 0 over 0 form. That's a big hint that it's a whole at 0. Plugging in 1 gets us 1 over 0. That tells us that there's a vertical asymptote. Make sense? Does that table make sense?
Yeah.
So there's a vertical, you can just say VA if you want. Okay.
We're doing
And then if you're wondering, the graph would look like this, vertical asymptote at 1. I can just graph this function basically, but just make sure there's a hole at 0. So something like that. Oakley Let's look at some piecewise functions. So you'll see number 5 is just more practice with that. Sorry if it feels redundant. Honestly, I put what I thought was like the minimum amount of practice that would be adequate to make sure you understand it. It's only 8 more. But number 6. We're going to ask the same questions about piecewise functions. So same story. When we eventually take a quiz on this, you'll just be asked, it'll be multiple choice, and it'll say like, oh, here's some piecewise function. Which of these choices fully describes the set of discontinuities for the function? I'm going to write a best-selling book. It'll contain the main piece of advice. It'll say, this is how you know people are interested in what you have to say. If they look like this. If they have to use their arm to keep their head from plummeting into their desk, then you know you have made a connection. You know you've touched their heart.
Mr. Hall, if you wanted to touch hearts, you maybe should have been a heart surgeon instead of a math teacher.
Yeah, probably.
Am I right, guys?
Am I right or am I right? Okay, number 6. We'll do a couple from here. The first one. I guess I have one really important question on this one that would hopefully get to this would get to the issue if you, what's up?
I'm just kidding. I said I don't remember how to do them, but I do.
Okay. Here's the question. Where is the only x value that could possibly have a discontinuity for this function? 3.
That makes sense.
Because this guy by himself is a line. And aren't lines continuous everywhere?
Yeah.
And this is a parabola. And aren't parabolas continuous everywhere? So the only place there could possibly be a discontinuity would be when you take these two pieces and try to put them together, right?
Yeah.
So if the two pieces, here's a parabola, here's a line. If they come together and connect at 3, no, it wouldn't be a hole. It would be no. So if they connect, so a piecewise
Oh, then it's
function.
continuous.
Yeah. So this one's gonna have a jump, and here's why. If I plug 3 in here, what do I get? 5. I'm actually gonna, you don't have to graph all these, but let's say I graphed it. For Maddie, who says she forgot everything about piecewise functions, apparently.
I just,
1, 2, 3, 4,
I
5.
remember.
So this is my x plus 2 for all x values to the left of 3. It looks Everyone okay with that?
Yeah.
So that's the line y equals x plus 2, but only when x is to the left of 3 or 3. And then here's a shifted right parabola. But what's so notice this number had a y value of 5, but this guy is going to have a y value of?
Not 5.
True. The whole parabola would look
4.
something like this. So it's only going to basically have, it's going to look something like that. Because the whole parabola would have to come down and touch the point 1, 0. So I only get that little tail of the parabola. But in any case, the fact that this produces the number 5 and this produces the number 4,
Makes a jump.
put yourself in a limit mindset, right? What's the left limit of this function as x approaches 3? 5. What's the right limit?
4.
4.
That's a jump.
Does the limit exist?
No.
No. But what we can say is that since the right limit and the left limit both exist and don't equal each other, then there's a jump. Okay? Let's compare that to B. B says x plus 5 when x is to the left of or equal to -2. And 12 over x squared whenever x is to the right. Okay, someone tell me, I'll give you a big hint. There are 2 values you need to be concerned with on this question. What are the 2 values that you need to focus your attention on? -2 and 0,
Ooh.
because there could be an asymptote, right? All right, so let's look at it. Do you guys think there is let's focus on -2 first. Is there a jump on this function at -2?
No.
No. How come you know it's not a jump?
They both equal the same y value.
Yeah. Plug -2 in. Why did I point to the 5? Okay. Plug -2 in here, you get 3. Plug -2 in here, you get
3.
3 again. That tells us there is no jump. Okay, at -2 at least. So in other words, it is continuous at -2. Okay, so no jump to worry about. I don't need to worry about that. But maybe make a note. Maybe make a note that it's continuous. At -2 because of those 3s. Now, this is a kind of a nuanced question. I want to see if anyone can give me a very good answer. Does this function have a vertical asymptote and why? Yes. So so why does it have a vertical?
Because it's saying that it's after to the right of -2, and so it's including the asymptote at 0.
That's a great explanation. Yes. So this function, this function takes hold everywhere to the right of -2, and his asymptote, which is at 0, is to the right of -2. So that asymptote would get included in the graph. That makes sense? So another way to maybe phrase it is, does this ignore everything else? Would this guy have an asymptote, vertical asymptote? Yeah, at 0, right?
Yeah.
Is 0 part of this interval?
Oh, so you just have
Yeah.
to check to make sure it's actually part of it.
Yeah, so the thought process could be very simple. We just say, identify, does this guy have an x value that produces a vertical asymptote? If it does, at 0, is 0 greater than -2? Yes.
To say it was like opposite and switched, it wouldn't be a vertical asymptote because it'd be to the left of it.
Yeah. Right after this, we'll do, C is going to be, no, C is a bad example. Let me look at D will be a good example of one. Spoiler alert. We'll do D right after this, but. Okay,
Do you have
so.
to write that a funny way?
Well, okay, so what we do, so I'll draw the graph too. The graph would look like this. Here's -2, the really important number.
Mhm.
Okay. To the left of -2, it's x plus 5. So this is a y value of 3. But to the right of -2, what does this graph look like? like this, right? So can you see the graph
Yeah.
form, kind of? That's what the graph would look like.
Okay.
So they connect. Do you guys see that? See why they connect at -2?
Mm-hmm.
And then do we see why the asymptote is included?
Yeah.
All right, so if you have any more confusion on this, hopefully this last example will clear it
So
up
do
for
you
you.
just write a vertical asymptote at 0 then? You don't have to do anything?
Yes, so the answer to the question is, the only discontinuity is a vertical asymptote at 0. You got a question, Scott?
No, that was.
Okay. We'll skip C. Like C also, think about C. You got that 1 over x,
Yeah.
who would have an asymptote at 0. Is 0 less than 2?
Yes.
Yeah, so it'll be included. But look at D. D's a very interesting one. This will be the last thing we do. The tragedy of late lunch. So sad. Okay. So, first question we're gonna ask is, do they connect? Plug in 3 here,
Get 2.
you get 2. Plug in 3 here, you get 2. So it is continuous. That tells us that it is continuous
At 3.
at 3. I should say when x is 3 to be more specific. And then would this guy by himself have a vertical asymptote?
Yes.
Yeah, at 0. But is 0 in this interval of numbers?
No.
No, 0 is not bigger than 3. So what this is going to look like, so here's why. If I graph this guy by himself, it's a parabola. And if I graph this guy by himself, it's a whoopty-doopty. But think of where I'm chopping them. I'm chopping them at 3. So I'm getting basically the left part of this parabola
Mm-hmm.
and the right part of the
So you're not-
whoopty-doopty. I'm missing out on the asymptote. So the overall graph would look like this.
So it's just continuous.
Yeah, so the answer to this question is it is continuous everywhere, or continuous for all x values. If you want to be really flexy, you could go continuous for all x values in the real numbers. And you'd
Whoa.
really be flexing your brain wrinkles on everyone. Anyway, that's it for the day.